Hello students, welcome to the class of physics. I'm Abhishek Datta, your physics faculty, and our discussion topic is Newton's laws of motion, right? So let's begin the chapter. But before starting the chapter, I just want to know that what we have studied till now. So we have studied motion. In that motion, we know what is distance, what is displacement. Even we know the basic difference also between distance and displacement, right? We know the speed, velocity, acceleration, right? I hope you guys remember what's the condition for uniform motion, that a particle object should travel equal distances in equal intervals of time. That means the velocity is constant in uniform motion. So in non-uniform motion, what happens? The velocity is not constant. That means in equal intervals of time, it travels unequal distances, right? We know what is rectilinear motion. That is when a body travels in a linear path, that is a straight line, right? Then the motion is called a rectilinear motion. We know what is circular motion. When an object moves in a circular path, then the motion will be circular motion. We also know what is curvilinear motion. When an object moves through a curved path, then it will be a curvilinear motion. And the last one, there is oscillation. When the particle will move in to and fro movement, then it will be called as oscillation, right? Okay. So in this chapter, we will deal with the cause of motion. When a particle can change its speed, when a particle can be accelerated or decelerated, or when a uniform motion can be a non-uniform motion, what are the causes behind this? We will explain in this chapter. So let's begin. So in this chapter, we will be dealing with the cause of motion, that is force. So let's take some examples and understand what are the different applications of force, right? So imagine a man who is standing in a stationary bus and the bus suddenly starts moving. Then what will happen to him? He will experience a push in the backward direction. Now, if the bus was moving and suddenly the bus stops, then what will happen? The man will experience a push in the forward direction. So why does this happen? Not only that, now in this diagram you can see that the man is applying a push to keep the trolley moving. So when the trolley will stand still, to keep the body in motion, the man have to apply the push force, right? In the next diagram you can see that the drawer was initially closed and we have to apply a pull to keep it open. In the next diagram you can see that there is a girl who is hitting a ball in the forward direction. So in all of the diagrams we see that the pushing, pulling or hitting objects change their state of motion, right? So what is the reason? In all the cases there is something which is common and is responsible for. What's the answer? That is the force, right? So what exactly the force? Force is defined as a push which tries to change or changes the state of rest or of uniform motion of the body. Suppose an object is kept stationary at a position and you are applying a force and keep it in motion, right? So to make the body in motion, you have to apply that force. Without the force, the object was remain in its standstill position, right? Let's take another example. Suppose our body is moving with a uniform motion, right? That means he travels equal distances in equal intervals of time. Okay, so to change its speed, what you have to apply? You have to apply a force to accelerate or decelerate it. So in all the applications of motion, force is involved. Suppose you want to make a body in motion, or you want to stop a moving body, or you want to change the speed of an object, is involved, right? Now, what are the different effects of force? There is a if some force or a set of forces acting on a body, then the following changes we can see. If a force or a set of forces is applied to a body, it can change the speed of a body. Now here is an example. Here the man is applying a force to the body and the body is in motion, right? Initially the body was standstill and after applying the force it's in the state of motion. And if we apply more amount of force to the body, then the speed will increase. Now the body is in uniform motion, but if we want to accelerate it, we have to apply more force on that object, or if we want to accelerate, we have to apply some value of forces to that object, right? Now, if a force or a set of forces are applied to an object, then it can cause the change in the direction of motion. Suppose you are traveling in a car and at some point you have to turn left or right. So what will apply? You will apply some force on the steering of that car, right? Then you can change your direction of motion. So when you are changing the direction of motion, you will feel a centrifugal force that is outward in nature. Therefore, everyone, when he or she is driving a car, he have to tie up with the seat belt, right? Now, if a force is applied to a body, it can also the change in shape of that object, right? Suppose there is an example. Initially, the spring was like this, and after applying the forces, it changes its shape, right? After applying the forces, it changes its shape. So we can say that after applying our forces, our body can change its speed, it can change its direction, and it can change its shape, right? Now just think, our system is already balanced. Balanced means it is maybe in stationary, right? So if you are applying a force to make the system unbalanced, then the system will change its state from stationary to motion, right? So an unbalanced force, only one unbalanced force or a set of forces are needed to make the system from balanced to unbalanced, that is from stationary to moving, right? That you can see in the diagram. Initially the whole beam balance was fully balanced, right? When a force is applied to it, it becomes unbalanced and it causes motion, right? Now, balanced forces and unbalanced forces. Balanced forces are always equal in nature, therefore they are called balanced. But unbalanced forces are not always equal. They have to be unequal to make the system unbalanced. Thus, it can causes the change of state of that object, right? Suppose there is a wooden block that is kept on a table and you are applying force in two opposite direction, right? If the force in both of the directions are same in magnitude, then what will happen? It doesn't cause any motion of that wooden block. If x, so here x is the amount of force that is applied in a right direction, y is an amount of force that is applied in the left direction. Now in some case, if x is greater than y, right, in some cases if x is greater than y, then what will happen? The wooden block will move in the right direction. In some cases, if y is greater than x, then the wooden block will move left, right? So due to the unbalance, the wooden block can change the state of it, right? Let's take another example. Here the two persons try to keep the stationary wooden block in motion. Initially the wooden block is fixed and they are applying some forces, but this is not sufficient because whatever the forces they are applying, that is fully balanced by the frictional forces of that object, right? That is called static friction. Now they are applying more forces. They increase their level of forces and they are applying more forces to it, and therefore the frictions also somehow increased. So their forces is less in the amount of static friction, right? Therefore the body doesn't change its state. So when the forces that is applied by the two person will be increased in some way, thus the forces overcome the friction, then the body starts moving. Ready? Right? In the last diagram we can see their forces are so much that they have overcome the frictional forces that is offered by the surface. Therefore the body starts moving in the right direction. That is the direction they were applying the forces. Right? Now here is some classification of forces. There is external forces and internal forces. Now what is external forces and internal forces? Now in that diagram you can see that the guys are playing tug of war, right? Four guys are at right side and one guy that is on left side. That is so unfair. But let's understand the concept. Internal forces is one type of forces where a force is applied to a body. Internal forces is a one type of force that is applied to a body by another body that is already in a system. If we can say about the four persons that they are at one side, so each of the person is applying a force to another person and they are in a system. So they are the internal forces. We'll give some examples, don't worry for that, to understand the concept of internal and external forces. Right? External forces is if a body is applying some forces to another body that is not in the system. Right? Now here is the classification of forces. What are the two kind of forces? That is internal forces and external forces that you can see in the diagram. That is, there are four persons and there is one person they are playing. And what about internal forces? If some forces is applied on a body by another body which is already in a system, what does that sentence means? That means the four persons are at one side and each one is applying some forces on another person, right? So four of them are at one system. So each one is applying some forces to another person. So this is called the internal forces, right? And there is an external agent who want to disbalance that system. Therefore, the external agent is applying some forces, right, to that system to make that system imbalanced. So here is the classification of forces. So there are two kind of forces. One is internal forces, one is external forces. So you can see in the diagram that four persons are at one side and one person on the other side and they are playing tug of war. Now, what about the internal forces? Internal forces means suppose the four of the persons, they are on the right side of the system and each person is applying some force on another person, right? In a system. So that kind of forces, that means the forces in a particular system, that is called the internal forces. That is the forces applied on a body by another body which is already in a system. We'll give some examples, don't worry for that. But just understand the basic concept, the basic definition of internal and external forces. Now here is the red one is the external agent, which is applying some forces in the rope. So the red one is not the part of the system, but he is applying some force on the system, right? So these forces are called external forces that is applied by the red one. Okay, and the four of the person that are on the right side, the forces between them that are called the internal forces, right? Suppose I'm giving a one funny example, that is you are having a Cadbury chocolate and you want to eat it. Okay, so each one of the molecule in that Cadbury, there is a tight bonding between each of the molecules of that Cadbury, and when you are just biting and when you are just going to eat it, therefore you are applying some force on that system. Therefore you are the external agent, and the bonding between the particles of that Cadbury is called the internal forces between them. Right? That's funny, right? Now let's take another example. Before that, we have to go through the definition. Now, internal forces, that is a force acting on a body or particle that is applied some other body that is already in a system. So let's go through to the definition of internal and external forces. What is internal forces? That is, it is the force acting on a body which is applied by some other body which is who is already in the system. That is called the internal force. What is external force? External force is a force that is acting on a body or particle by another body who is not in the system. That's the basic difference, right? Let's take some examples that helps you to understand. Here Ram and Sham, they are playing tug of war, and if we consider Ram, Sham and the string to be a system, then the pulling force acting on Ram due to Sham is a part of system. In the other way, the pulling force acting on Sham due to Ram is also a part of system. So these forces are called internal forces, right? Now, here you can consider that Ram to be a system. Ram is only our system, and the force experienced by Ram due to Shyam, that Shyam is applying some force on that system. Therefore, Shyam is the external agent, and the force due to Shyam is called the external force, right? So guys, let's start what's about Galileo's experiment and understand the concepts behind it, because these concepts are very much useful to understand Newton's first law of motion. From the conclusions of this experiment, Newton derived three of his laws, that is Newton's first law, second law and third law. Okay, so guys, as you can see in the left hand side diagram, that there is a block of mass that was fixed at the bottom point, and after applying some force on it, it starts moving in upward direction, but its velocity gradually decreases when it was moving in upward direction, right? In the right hand side diagram, what you can see, that there is a ball that was fixed at a point, and after applying some push force, it starts moving in downward direction and its velocity increases, but after reaching the bottom point, it starts moving uniform velocity. So what you understand from it, that is, if unbalanced forces do not act on a body, the body will either remain at rest or it will move in an uniform velocity, right? That means no acceleration will be there. So let's see what was the experiment, right? Slideshow. Now, as you can see in this diagram, that there is an object that was at a particular height, and when it is released from that particular height, its speed gradually increases. But after reaching at the bottom point, then there is no force was acting on it. Then it will move with uniform velocity thereafter, right, in a fixed direction. That is explained in the second conclusion, that when a body is moving and no unbalanced force is acting on it. So here after reaching to the bottom point, there will be no unbalanced force will acting on that particle. Therefore, the particle will move with uniform velocity. No acceleration will be there as the surface is frictionless. So we can say that when the body will move in uniform velocity, there will be no unbalanced force will acting on it, as we are assuming that the surface is frictionless. So when there will be have some friction, what will happen? That it will not move with velocity, it will be deaccelerated, right? So in the third conclusion, it was explained that if unbalanced forces are acting on a body, then it will accelerate or it will decelerate, right? Depending on the motion of the particle. Now, there are three kind of forces that we will discuss. One is weight of the body, another is normal force, and the last one, that is tension force. Right. So, what is weight of a body? Suppose let's assume that a body having some mass of 50 kg or 70 kg or 80 kg. How can you determine the weight of the body? Weight is basically the force of gravity by which our earth is attracting every object, that will say in the next chapter, that is gravitation, right? So we can determine weight as mass into gravitational acceleration. What is gravitational acceleration? The acceleration by which an object is attracted towards the earth's surface. Remember the story that when an apple fell down on Newton's head, Newton's think about it, why the apple fell down on its head, and then he discovered universal law of gravitation. We'll discuss it deeply in the next chapter. Till now, you have to just remember that weight of a body is equals to mass into gravitational acceleration. Right? It's a one type of force by which our Earth's surface is attracting every object. If we are applying a force on the Earth's surface, then our Earth will apply the same amount of force on every object, and that force will act perpendicularly to the object. That does not depend on the position of the object, right? And that force is known as normal force. Next, we'll come to tension force. What is tension force? If an object is tied up with a string and the string is fixed at some point, then what will happen? There is a force, that is a downward force, that is the weight of the object, and to balance the downward force, there will be equal and opposite upward force will be there, that is along the string, and that is known as tension force, right? So whatever will be the weight of that object, the tension will be equal to the weight of the object. Okay, now move. So what is Newton's first law of motion? It states that a body continues to be in the state of rest or of uniform velocity until and unless an external unbalanced force is acting on it, right? So if a particle is in rest, it will continues to be at rest if no unbalanced force is acting on it. In the other way, if a particle is moving with a uniform velocity, then if no unbalanced force is acting on it, then it will continue to move with uniform velocity. No acceleration or no deceleration will be there. I hope you guys are understanding the concepts of this chapter. If you have any doubt, you can inform us.